So today we are going to talk about polar coordinates. Now, sometimes all throughout your career in high school and college so far, you would have been talking about the rectangular coordinates. Rectangular coordinates. Now, what are rectangular coordinates? Rectangular coordinates are the usual coordinates that we deal with. Like if you say 3 5, then the x coordinate is 3 and the y coordinate is 5. So 3 5 represents a pair of rectangular coordinates. Now they are called rectangular coordinates because x is on the horizontal, y is on the vertical, and so we have rectangular coordinate axis to represent the coordinates. That's why we call these coordinates rectangular coordinates. But sometimes rectangular coordinates are not good enough to represent various mathematical objects. And one such mathematical object is a nice round curve. Now if you look at this nice round curve, it is not rectangular. This curve is not vertical or horizontal, it's curved. So to represent this curve, it is best actually if you use a different set of coordinates, not rectangular coordinates, but a different set of coordinates known as polar coordinates. Now you can see at the top of this graph, this the equation of this figure is written using r and theta. And now we will talk about this a little later. So r and theta are called polar coordinates, and it is just like the xy coordinates would represent a graph. The polar coordinates too can represent a graph. Okay, so so the main reason why we are using polar coordinates is that it's another way of representing a mathematical object such as a graph, right, and a way which is much more conducive to the curved nature of the graph. So we use polar coordinates for that. Alright, first of all, let's take a nice pair of rectangular coordinates that we are aware of. Take the point 1 1 in the rectangular xy axis. Now when you say 1 1, what do you really mean by that is that we have one unit this way and one unit that way. So we have the point 1 1, and 1 1 is a rectangular representation. Now let us see how we can represent this same point using polar coordinates. What we do is this: we join the origin to this point by a ray, by a line, okay, and then we take the length of this line as the polar coordinate r, okay, the first polar coordinate, and then we take the angle that this line would make with the x-axis as the second polar coordinate. So you should remember that the first polar coordinate is always a number which represents a distance, while the second polar coordinate is an angle. Unlike in the rectangular coordinates where both coordinates are distances, in the polar coordinates only one coordinate is a distance and the other coordinate is an angle. So we will talk how we will get these figures. Now if you actually calculate this length, you can find that it is square root 2, and that will be the first polar coordinates. And if you calculate this angle, you can show that it is pi over 4. We will show that later. That is the second polar coordinate. So the first polar coordinate is square root 2, the second polar coordinate is pi over 4. So therefore the polar coordinate pair can be written as square root 2 comma pi over 4. So we write the polar coordinate just like the usual coordinates using parentheses, but the first one is the distance to the point from the origin, and the second one is an angle that it makes with the x-axis. Right, so this square root 2 pi over 4 is the polar representation of the rectangular coordinate 1 1. Now let's see how we got these numbers. How did we get the first polar coordinate, the square root 2? If you go back to our figure, you will see that here is our point. Now we want this number. Now because this point is 1 1, this y height is 1, and so is the x height. So we have 1 here and 1 here. So if we now we can use 1 here and 1 here. So now we can actually, if you want to find r, we can use the Pythagorean for the rectangular coordinates, and then we get 1 squared plus 1 squared equals r squared. So r squared is equal to 1 squared plus 1 squared, which gives you r squared equals 2, which gives you r equals square root 2. So that's how we get the first polar coordinate, which is square root 2. Now how do we get the second polar coordinate? Well, you can use the same triangle, but now you can use trig. Now if you remember what tangent is opposite over adjacent. So this angle, the tangent of this angle, if you call this angle theta, so let's call this angle theta. So if I call this angle theta, okay, and then what we have is, from this triangle we have tangent theta is equal to opposite over the adjacent, which is y over x, right? And y, this one is 1 and x is also 1 in our case. So tangent theta is equal to y over x, which is 1 over 1 is equal to 1. So we have an equation, tangent theta equals 1. Now from trig you know that there are many angles actually whose tangent is 1, but we certainly know of a simple unit circle angle from the first quadrant, which is of course pi over 4. So one possible candidate for theta is pi over 4. So theta is pi over 4 and the r is square root 2. So we have the first polar coordinate as square root 2 and the second polar coordinate theta as pi over 4. So the polar representation can be written as 2 pi over 4. Now this is only one polar representation. Now a nice thing about polar coordinates that if you look at the rectangular representation, this is just 1 1, that's it. There is only one single representation, but there can be several polar representations for this one rectangular representation. Now we got one of them. One of them is 2, actually this should be square root 2, this is typo, let me, that would be square root 2 pi over 4. This is just one of them. How do we get the others? So let's look at it as a problem. Alright, so example 1, find 4 different polar representations of the point given by the Cartesian point 1 1. Now when you have a problem, the very first thing to do is to find one pair. So just like we did before, what we do is we did it, but then let's do it again. So first thing is to find the r. So how do you find the r? R is equal to x squared plus y squared over square root, and then we have 1 squared plus 1 squared square root, which is square root 2. How do you find theta? Theta is tangent theta is y over x, so you divide the second coordinate from the first coordinate, so you get tangent theta is equal to 1, and then you get one solution as pi over 4. Now how do you find the other solutions? Well, now this is pi over 4, okay. Now you can get another angle. Now how do you get another angle? Well, what you can do is we can go around like that, go one full circle and come back to the original point. So how long did we go? We actually went 2 pi plus pi over 4. So 2 pi plus pi over 4 is another angle. So 9 pi over 4 is another angle. If you want, we can do it again and we can do 2 circles. Now if we do 2 circles and come back, okay, and then we will have another angle. And so if you have 2 circles, then we have what? 4 pi plus pi over 4, which is 17 pi over 4. So we can have different angles. So for the 9 pi over 4, we get another representation, which is what? R is still square root 2, but the angle is now 9 pi over 4, which you got after going one circle. Now if you go 2 circles, then we get 17 pi over 4 with the same R, but with 17 pi over 4 we get a third representation for polar coordinates. Now these are the angles in the positive direction. If I want, I can also take the angle in the negative direction. Now recall, this is our original point. So instead of going this way, I can go this way. Now if I go that way, let's see what happens. If I go like that in the negative direction, what will be my angle? Well, it will be a pi over 4 subtracted from 2 pi, right? Because this is almost a circle, but you subtracted 2 pi over 4, right? Okay, so it will be what? It will be 2 pi minus pi over 4, which is 7 pi over 4, but we are going in the negative direction, so it's negative 7 pi over 4. So yet another representation will be r is still square root 2 and theta will be negative 7 pi over 4, which is a negative. And then you can go, now here I went one circle in the negative direction. If you really want, you can go another circle in the negative direction or a third circle in the negative direction, and we get a whole set of new negative angles. So likewise, there are infinitely many representations, but I have written 4 of them as was asked in the problem. So all these 4 representations, polar representations, represent the same rectangular coordinate pair, which is 1 1. Actually, we will learn in class tomorrow that r can also be negative, and the same 1 1 point can be written with the negative r as negative square root 2 and pi over 4. But let's do it in class tomorrow. In the meantime, here is a video exercise for you. Find 4 different polar representations of the point given by the rectangular coordinate. So like I did before, first find r and theta and find one pair, and then by going clockwise and anti-clockwise find the other pairs. Have a great evening. That's it for today.